Hey everybody, it's Ryder Timberlake with some coding. This particular little mini series is going to be on Elasticsearch. Basically, Elasticsearch is probably something you've heard of before that does searchy things. Hence the series, because we're using it at work, and I've not really worked with it before, so I know almost nothing about it. It's written in Java. It does NoSQL-y, searchy things that are in shards and nodes and clusters, and it's like distributed or something. Let's find out more. So when we're talking about a technology that I'm trying to get to know, that I really know nothing about, one of the best ends, of course, is the people you know who know that technology. So I will be talking to Toby at work and getting more information from him as to what I should do. Some would argue that it's a waste of time to even start looking at this really until I've done that. I wouldn't argue vociferously with those people, but I'm wanting to get started with it, dig around a little bit. On my work computer, I already have cloned down the Elasticsearch repo and sort of tooled around in there a little bit. It is a large project, so just coming in from that angle of like, hey, I'm going to look at the code and get a feel for it, is probably not the best angle. There, of course, for a more manageable library, one might opt to do that. I was wanting to do a technique that I like to use for smaller, more manageable projects, which is start with the first commit and look at the commits from there. Look at the change for each successive commit. um, Turns out in the Git GUI, I usually use GitHub Desktop. That's not really feasible. There might be others. It's not feasible because it's not sufficiently performant. Like you can only go down. There's not an option that I've seen in that GUI which enables you to go all the way back to the first commit and kind of work up from there. You're always working back from the most recent commit. Seems like saying that out loud, I'm like, well, that's ridiculous, Ryder. They should definitely have that functionality. But I looked and I searched for it, wasn't able to find it. Does definitely not mean it doesn't exist. It would make an awful lot of sense for that to be the case. And of course, there's stuff in the bare git command line interface, which I can use to go back and look at the first thing and to include the diff in the log. There are definitely options to do that. But these are all topics for another day. We're already a few minutes in, basically. I want to learn Elasticsearch. So what I'm probably going to do is go and maybe look at some tutorials. One issue I often have with tutorials is it's rare to find one which is test driven, test or behavioral driven, whatever you want to call it, where someone is indicating the features or the behavior that they want first, and then based on that, they're writing the code, and they're making small incremental changes and switching back and forth between those two sides very quickly. It's rare to find tutorials structured like that, and some tutorials actually in this dichotomy are completely on the other end of the spectrum, where it's like, all right, let's build. All right, let's fire it up. And I can't stand that way of building a thing. And there are a tremendous number of pitfalls in terms of like concrete pitfalls that could happen, but all subsumed under these larger umbrella pitfalls of like, well, you don't actually know then until you push it, and you may have made some very serious assumptions about a very narrow spectrum of the ways in which this could be used, and now you're wiring up, and now you're figuring those things out. Those things should have been feeding into your process all along the way so that you could have some sense that what you're trying to build and what is actually being built by you are sufficiently aligning. Yeah. So Elasticsearch, we are probably going to look for some tutorials. This first little dive into it, we might just kind of futz around on the internet, Googling and such. If I'm going to use a library interface for Elasticsearch, it is likely to be Elixir, just because Elixir is my favorite thing right now. But we'll just see. Google Chrome. Oh, and I'm not going to screw up like last time and not share my screen. I'm going to totally share my screen, and it's going to be great. It's going to be great. We'll pop open CamDesk here. A great little program. All right, screen sharing, great. That's what I want. Go ahead and hide this, and let's pop open another Chrome window, and let's look around. Elasticsearch. So I'm not going to get as specific as I actually want to be and say Elasticsearch tutorial Elixir, because that's awfully specific. Or Elasticsearch tutorial TDD. I might do that. Elasticsearch, hello world example. TDD.NET TDD example. That's not what I want. In the example, Elasticsearch is used as a data storage. That's interesting. Well, that could be fun. Just want to take a look at this. Product retriever, class retriever product from a data storage. Product is not found. The storage engine is not available. Given ID. All right, I'm already not. Let's not to say that we might not look at this, but let's not. I try to deduce a lot from the language and such of tutorials I'm looking at, and there's a certain level of precision in the language and sort of overall niceness. I mean, it's very kind of ineffable, difficult to f. Yeah, it's hard to describe what I'm looking for exactly, but I'm likely to see it. So I've heard of this Elk, Elasticsearch, Logstash, and Kibana. It's frequently touted as an alternative to Splunk for data analytics-y stuff. And it's pretty cool, and I would like to know how to use it. All right, so you're doing all this stuff. Server, loaded module, initialize, starting, install with tar file, right, install with commands, da, 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 da. All right. Seems like I'm seeing a lot of like how to get spun up, and now we're looking at the Elasticsearch. What is an index? Is a collection of documents. Bookstore is a document. Index is used for indexing, blah, 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 blah. What is a type? An index is similar to database in relation. Nope. Elasticsearch in 5 minutes. Makes it easy to run a full-featured search server. So easy, I'm going to show you how in 5 minutes. Well, that's appealing. JDK 6 or above, blah, 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 yeah, Java. You can access it, which returns this. Build hash, build timestamp. So clusters, Lucene, I don't even know what Lucene is. I just know that Elasticsearch runs on it and has shards and stuff. Yep, so we're curling in a user Dilbert. So yeah, we're updating his name to Dilbert Brown. Did we create him before? Not in this flow. There's an assumption that he's an existing record, and I'm not super fond of that. Because when did I create him? Huh? I don't see him earlier. Yeah, so that lack of explicitness where it's like, here, now I'm doing a step and I'm updating something which ostensibly exists in the database, but it's a tutorial and I didn't actually show you. I'm not terribly fond of that either. Loading sample data. Complete works of William Shakespeare, suitably parsed into fields. Whoa, that's a big JSON file. Unsurprisingly, I guess. All right, is this Java? You're not. I would suspect this is Java. Put Shakespeare, but maybe we're just interacting with the REST API here. I was just looking at the schema and it was making me think Java. But that was probably an unfair assumption. All right, this is my favorite so far. Yeah, that matches the name of an index we've loaded will work. Index patterns, add new, log stash data. When you define an index pattern, indices that match that pattern must exist in Elasticsearch. Those indices must contain data. In order to create that index, I'm assuming it means when you define an index pattern, because otherwise creating that index should fail. Define, I'm assuming, is being used here to mean the instruction that will then create the index. Mm-hmm. 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 And the values are, so we're talking about Kibana now, which I have not used before and would be useful, I think. Try it, select the bar index pattern into the following query string in the query bar, account number, less than 100, balance greater than 47,500. Uh-huh. Hmm. Okay. I thought we were doing the works of Shakespeare. What's all this about? Hmm. Was that just for one? Hmm. You can build visualization from saved searches or enter new search criteria. Default search matches all documents. Initially, a single slice encompasses the entire pie. All right, so I'm just looking over a lot of stuff. Bucket aggregation. Da, 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 da. All right, so actually, Elastic, what's this top level domain? Yeah, that's sort of what I figured. Machine learning in Elasticsearch, that's shiny. Not in scope at the moment for what I'm trying to do here. Try hosted Elasticsearch free for 14 days. Basic search, retrieving and deleting data through CRUD REST APIs. Basic text analysis, basic search queries. So Elasticsearch is a distributed place you can put your data in order to query it faster. That's like, yeah, distributed and robust or something. I realized that I could just go and I could read somebody's description of what Elasticsearch is and what it's for, but so often those things tend to be really just not accurate in my opinion. Sometimes even like the designers, they don't really understand what it is they've built. They just understand how they think they want most people to use it. Um, I realize that's kind of like a dreary, thoughtless, overly critical take on the information that's out there. But okay, that's interesting. So here we do have some TDD. Oh, and originally, again, those search terms I think did include TDD, so we may want to get rid of that. Oh my gosh, developer writing tests. If people really have this objection, um, play around with the UI. I cannot follow what you're trying to say here. Test-driven example with Mockito, part 7. Ooh, there it was in Portuguese, but then I'd have to translate for everyone also, and I'm not sure I want to do that. Uh-huh. Vamos ver, vamos ver. Lançamento do livro Construindo APIs Testáveis com Node.js. Construindo APIs Testáveis, exemplos do dia a dia para a construção de aplicações, blá, 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 testes em JavaScript, diferença entre fake, spy, stub e mock. Não, acho que não. We'll do something else. All right, so let's get rid of this TDD part and just say Elasticsearch tutorial. Yeah, just Elasticsearch tutorial. And here we are, and it's bumping us back to that actual Elasticsearch site again, which I don't hate that idea. Highly scalable, open source, full text search and analytics engine. Allows you to store, search, and analyze big volumes of data quickly and in near real time. Okay, okay, all right. You're right, guys. I do like that explanation, and it seems pretty clear. It is generally used as the underlying engine technology that powers applications that have complex search features and requirements. You run an online web store where you allow your customers to search for products that you sell, to store your entire product catalog and inventory, and provide search and autocomplete suggestions for them. Run a price alerting, blah, 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 blah. So actually, I did like that. Oh, that's already where I am at the end. Basic concepts. Oh, okay, maybe I should just go straight to the docs. I'm fine with this. Near real time. What this means is there's a slight latency from the time you index a document until the time it becomes searchable. A cluster is a collection of one or more nodes that together holds your entire data and provides federated indexing and search capabilities across all nodes. A cluster is identified by a unique name, which by default is Elasticsearch. This name is important because a node can only be part of a cluster if the node is set up to join the cluster by its name. So it's got to be a unique name. And you can only get on the cluster according to your name. The same cluster names in different environments. The node is set up to join the cluster by the name of the cluster. Okay, gotcha. Might end up with nodes joining the wrong cluster, right? All right, so the cluster is a group of nodes. The nodes are servers. A node is a single server that is part of your cluster, stores your data, and participates in the cluster's indexing and search capabilities. Just like a cluster, a node is identified by a name, which by default is a random, universally unique identifier. That is assigned to the. Anybody know the difference between a UID and a GUID? Is there a difference? Are they the same thing? I thought they were the same thing. You can define any node name you want. If you do not want the default, this name is important for administration purposes where you want to identify which servers in your network correspond to which nodes in your Elasticsearch cluster. A node can be configured to join a specific cluster by the cluster name. Right. So we need to keep those names unique so that our nodes are joining the right clusters. By default, each node is set up. Okay, so by default, the cluster is named Elasticsearch. By default, the node is set up to join a cluster named Elasticsearch. You do need to name these things explicitly, which that's not really. I mean, that could be a gotcha, right? But that's not. There's nothing unreasonable or weird about that. Which means if you start up a number of nodes on your network and assuming they can discover each other, they'll all automatically form and join a single cluster named Elasticsearch. In a single cluster, you can have as many nodes as you want. Furthermore, if there are no other Elasticsearch nodes currently running on your network, starting a single node will by default form a new single node cluster named Elasticsearch. Okay, I already have a really dumb question, which is, like, if the nodes are servers, can you have multiple ones on the same machine? I mean, I'm assuming you could if they were like all in containers or something. I think ideally, and what's the ideal? How ideally would you organize those? Index is a collection of documents that have somewhat similar characteristics. For example, you can have an index for customer data, another index for product catalog, and yet another index for other data. So this is one reason I closed that other. I closed that one of those other tutorials we were looking at because it was saying an index was analogous to a database in relational database land, and what I wasn't fond of that, because maybe that's actually what he meant to say, but it seemed like what he was maybe wanting to say was that an index is analogous to a table in relational database land. And if that was the case, and he was saying this other thing, then I wasn't a fan. But maybe he did mean like a database of multiple tables, product catalog, index for customer data. Seems like those would be tables, though, not. Yeah. Delete operations. In a single cluster, you can define as many indexes as you want. Within an index, you can define one or more types. A type is a logical category partition of your index whose semantics is completely up to you. Okay. In general, a type is defined for documents that have a set of common fields. For example, let's assume you're on a blogging platform and store all your data in a single index. In this index, you may define a type for user data, another type for blog data, and yet another type for comments data. So are those like columns, or are they like something else? Document is a basic unit of information that can be indexed. For example, you can have a document for a single customer, another document for a single product, and yet another. So this document terminology is common to Mongo, for example, which is the only other NoSQL-y type thing that's still database-y that I've worked a little bit with before. This. You can store as many documents as you want. Note that although a document physically resides in an index, the document actually must be index assigned. Shards, here we go. An index can potentially store a large amount of data that can exceed the hardware limits of a single node. Yes. For example, a single index of a billion documents takes up to a terabyte of disk space, may not fit on the disk. Single node or maybe too slow to serve search requests from a single node alone. To solve this problem, Elasticsearch provides the ability to subdivide your index into multiple pieces called shards. When you create an index, you can simply define the number of shards that you want. Each shard is in itself a fully functional and independent index that can be hosted on any node in the cluster. Sharding is important for two primary reasons. It allows you to horizontally split or scale your content volume. It allows you to distribute and parallelize operations across shards, potentially on multiple nodes, thus increasing performance or throughput. The mechanics of how a shard is distributed and also how its documents are aggregated back into search requests are completely managed by Elasticsearch and is transparent to you as the user. Okay, that is important to me. In a network cloud environment where failures can be expected anytime, yep, it is very useful and highly recommended to have a failover mechanism in case a shard node somehow goes offline or disappears for whatever reason. To this end, Elasticsearch allows you to make one or more copies of your index shards into what are called replica shards, or replicas for short. Replication is important for two primary reasons. It provides high availability in case a shard or node fails. For this reason, it is important to note that a replica shard is never allocated on the same node. Allows you to scale out your search volume throughput since searches can be executed on all replicas in parallel. To summarize, each index can be split into multiple shards. An index can also be replicated 0, meaning no replicas or more times. Once replicated, each index will have primary shards, the original shards that were replicated from, and replica shards, the copies of the primary shards. The number of shards and replicas can be defined per index at the time the index is created. After the index is created, you may change the number of replicas dynamically anytime, but you cannot change the number of shards after the fact. After the index is created, you may change the number of replicas. You cannot change. Okay, so you can change the number of replica shards, but you can't change the number of shards once you build the index and shard it at the same time. Okay, by default, each index in Elasticsearch is allocated 5 primary shards and 1 replica, which means that if you have at least 2 nodes in your cluster, your index will have 5 primary shards and another 5 replica shards. Oh, I don't like this language. Each index in Elasticsearch is allocated 5 primary shards and 1 replica per shard is what it should say. Yeah, that's really what it should say. Is allocated 5 primary shards and 1 replica shard per shard, or 5 primary shards and 5 I mean, if 5 primary shards and 5 replicas is confusing, then 5 primary shards and 1 replica for each of those shards. Because this is confusing, this language right here. Assuming I'm understanding properly what it's saying. Each Elasticsearch shard is a Lucene index. What is Lucene? I'm not gonna. This is a shiny side path. I'm not going to go down the rabbit hole here. Don't worry. I'm capping this at 1 minute. Apache Lucene is a high-performance, full-featured text search engine library written entirely in Java. Thank you. That is sufficient. With that out of the way, let's get started on the fun part. Elasticsearch requires at least Java 8. I am pretty much, yeah, I've got Java 8. Why did I do this? Whoa, no, it's like dash, yeah, it's version. 1.8. I feel like that's the same. It is recommended that you use, yeah, 1.8.0, blah, 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 131. Mm, 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 up to grade. All right, so it's going to try and upgrade our Java SDK. Installation example with tar. I would rather use Homebrew. I'm sure you've got a Homebrew package for this. Homebrew Elasticsearch. Because it's easier for me. Here we go. I mean, what I could do is just fess up to the fact that I've pretty much never, well, have really only installed things from, curling and tarballs if some tutorial is holding my hand. Oh, shameful. Yeah, so I'm more, here we go. Brew install Elasticsearch. What? Multicast enabled. Mine says blah, 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 blah. Uh-huh. Sure. It's taking its sweet time to update Homebrew. It does appear to potentially be doing something. All right, so we'll get to this here in a moment. We're switching back and forth very rapidly. This does not look promising. This looks deviant. It looks deviant to me. All right, so I'll just let that crunch for a while. MSI installer package. Sure, I wouldn't mind. Half my viewers just threw up in their mouth. We then go into the bin directory as follows: cd Elasticsearch 5.5.0. Now we're going to start our node in single clusters. So this sounds pretty straightforward. I mean, I just don't like curling random endpoints that people tell me to curl. That's another piece of this. I sort of trust Homebrew. No available formula with the name Java. Brew task upgrade. This may not work either, but I think man brew cask. Sure. Brew cask command. Brew cask upgrade Java. Unknown command Java. Brew cask. Just brew cask. Maybe I'm going about this wrong. Maybe there is no brew cask upgrade, but if the formula is already installed, regardless of the origin, whether it's like these traditional packages or from a cask, all I have to do is say, oh, I had seen that a moment ago too. I'm going to show my ignorance. Brew. Yeah, so those are the ones I've installed right now. I'm assuming. Do I not have Java? That would be absurd to me. Yeah, it's already installed. Well, maybe there's just not an upgrade path in the same way, although I'm really suspicious as to whether or not I'm not just kind of missing something obvious. I'm very suspicious that there's something I should be doing here differently, but that's okay. All right, so that should be done here in the next couple of minutes, and I'm rounding out. I think I've already gone more than a half hour, so, and I'm not gonna force this episode on to actually have this thing installed first. Basically, what did we learn? Well, we learned about Elasticsearch, which is a way to do searching when you need to have high throughput, highly available, uh, potentially complex search functionality that you want to provide autocomplete and different things or whatever. Um, yeah, some of the high availability stuff comes through the fact that you are packing your clusters full of nodes representing individual servers, and these nodes are all typically sharded. It sounds like they will typically be uh, an index, and these nodes are organized into indices which I believe are analogous to tables in relational database land, and we'll talk more about that in the future. And those indices can be broken further into categories called types. So you might have like a customer data type, and whatever those examples were, product type, um, uh, different things. And each index by default is going to be sharded into 5 shards, and then each of those shards is going to have a replica shard supporting it. So, and those shards should live in different nodes, the shard and the replica shard. I'm not clear about the 5 primary shards per index, if those, it's okay for them to live in this, or even preferable for them to live in the same node. I'm not really certain of that. So this sharding and pulling everything back in and aggregating it is entirely handled by Elasticsearch in a way which is supposedly transparent to us as users of the product. Your password may be necessary. Do. All right. Yeah. 5.5 is the latest version. There's this elk stack, which is a open source alternative to Splunk. Splunk, of course, can end up costing a lot of money at higher sort of enterprise levels, and then at the level of a small business. I feel like elk gives you a lot, though. Guys, I'm talking out of complete ignorance here, folks. I'm talking out of complete ignorance here, but. Let's see here. Yeah, exploring your cluster, modifying your data. We found some nice tutorials. One of them, I think, was at this. The Elasticsearch stuff seems actually to be a really good place, excuse me, to go and look at this documentation. We did find some other interesting things I might want to look back over at some point. We did find a TDD in .NET sort of example implementation Elasticsearch. One of the ones that we found at this Elasticsearch documentation was actually about the collected works of Shakespeare. That's what the Shakespeare.json, which was a 24 megabyte JSON that we downloaded. Oh, all right, that's sure. Oh, that's going to take a second to crunch. That's going to take a second. And this is, whoa, cool. Play name Henry IV. Text entry. No more thirsty entrance of the soil. Oh man, every line Wow. Every line of every play. Oh my goodness. That's intense. That is super intense. Okay, so this I think would be an index. And then within this index, we could have a category for or a category for the play name, a category for the speaker, um, I believe. And this index is going to get sharded by default into 5 shards with 5 backup shards in a separate node, because if we have our replica, our backup shards in the same node, it's not going to give us anything if that node containing the primary shards goes down. Interesting, interesting, interesting. Holy crap. Yeah, we could spend a long time going through this. Wow. Wow. Now you could like hit the Guggenheim archives or something, an automated tool to crawl and grab and parse all this for you, but I'm assuming that's what was done, but I am still really impressed with this. This is super neat. All right, all right. So we talked about summarizing what Elasticsearch is. Again, my goal for this little mini series, just get acquainted with Elasticsearch, actually kind of understand what it is, what it does. Yeah, I'm going to want to build at least a toy example, maybe a couple toy examples. I don't know. I don't have a super clear vision for this series. Basically, we're doing Elasticsearch stuff at work. I don't understand or know hardly anything about it. And so like from a ground zero level of like virtually no knowledge of Elasticsearch, I want to learn some stuff about Elasticsearch, and you are welcome to come and learn with me. Um, yeah, so hope you enjoyed the show, and I'll see you next time. Oh my gosh, where's my thing? How do I turn it off? Oh, this is so embarrassing. This never happens. You